the next expert talk, which will be delivered by Dr. Abhishek Datta from Izmir Institute of Technology, Turkey. He's a professor there. I mean, he's a assistant professor there. So we call him Dr. Datta, not Professor Datta. And he is also, he has his startup, Simuligence. So over to you, Dr. Datta.
Thank you. Thank you, Mrs. Mukherjee. First of all, it's a great honor for me to be part of this program, and probably the biggest initiative for this is thanks to Mrs. Mukherjee, Payal Mukherjee, and who actually kept on this continuous, dialogue between us. Thanks also to Professor Modgolia, Kanan Modgolia, and Dr. Chandan Bose for this warm offer for presenting ourselves. Basically, yeah, indeed, I'm Abhishek. I'm Abhishek Datta. I am from currently I'm an associate professor at Izmir Institute of Technology in Turkey, and I have this startup Simuligence that I made it just after COVID. So I remember dates like that these days, before COVID or after COVID. It was in 2021, and since then I have been focusing. Keeping aside my conflict of interest and things like that, which are very important in this part of the world, I'm sure as well as in any other part of the world as well, trying to focus on things that are, let's say, not connected directly to my own research, but yet still complementary to my skills. It was a very nice presentation from Dr. Gupta as well as from the previous presenters as well. Dr. Gupta had clearly mentioned the problems, and I think this is it more or less covers a big aspect of this today's presentation. However, I'll talk from a little bit from a different perspective. I have a very few slides actually, to be honest, and that's basically on the priorities of European Union on the aspects of digitization, basically on the fourth industrial revolution. And here, of course, an integral part of it is CFD. Why I focus on the European Union? Because as you have probably seen, my company is registered in Lithuania. It's a fully registered company, and it's in Vilnius, the capital city of Lithuania, and we are there since 2021. So let's go to the next slide. A little bit about Simuligence. We are focusing on three principal domains: environmental, health, and energy technology. These are, of course, three of my personal strong areas as well. I'm trying to combine machine learning and artificial intelligence algos to play a pivotal role for product and process development, especially in the context of digital twin technology. Under the scope of digital twin, so the scope of Simuligence basically includes the digital twin conceptualization. We do modeling and simulation, and here, of course, lies my own personal expertise with the algorithms of finite element and finite volume. Then I am having a team which works on communication and connectivity issues using edge and cloud computing. And of course, we are trying to develop some good machine learning algorithms, AI algorithms using PIN, physics-inspired neural networks. Out of scope for us currently is the human-computer interaction and the human-robot interaction, which we are dealing only with collaborations across Europe. So these are this is the main scope, or rather, these are the main scopes of Simuligence, and we are focusing principally on the three domains, as I've mentioned. Personally, I have a background in chemical engineering, as was also mentioned by Mrs. Mukherjee, I think. I have almost 15 years of experience in numerical modeling, and I have a team with a mechanical engineer with 5+ years of experience in simulation and validation, a computer science graduate with 12 years experience in software development, and an applied mathematician with knowledge of algorithm developments. So this team basically tries to work together. This is our team, a very small team, as you can see, and it perfectly falls under the SME definition for European Union. So we are poised as a SME, and we are trying to, or rather a micro SME in that sense, to be more specific. And the whole idea is basically that we try to help companies, as well as we are now venturing into a little bit other things, not just the company work, and I'll come to that in a few slides from now. So this is standard vision, mission, and values. I skip it for now. Yes, so indeed, Dr. Gupta was mentioning a very valid point that the use of commercial license is still a big issue in across the in India as well as in across the world. I have personally faced myself this issue as well when I had approached companies, and they clearly told me that this is the deadline. The deadline is 6 months or 1 year or something like that. Depends on the projects, of course, and you have no time to improvise or work on it on an improvement scale. You just have to deliver. So there is at one side the money or the happiness of finishing the work, and the other side of your personal happiness of you using an open source. At some point, there was had to be a compromise, and we had to go for commercial licensing. So this is an aspect which, unfortunately, the industry is also a little bit responsible about it. That when they have a legacy software and they have their own engineers with this license, they generally do not want to have any other, even outside even CFX or ANSYS, they don't want to go into any other softwares as well. There are a lot of new softwares coming up from the Dassault systems, and also these are also upcoming commercial softwares, but the market is really, really blocked by, or rather monopolized by, commercial licenses. Small things that I'm proud of saying on behalf of Symbologens we did was trying to improve this existing argon oxygen decarbonization process for a steel company. Let me not disclose the steel company now. It's an European steel company, where we actually reduced the whole idea of this mixing time. 10.6% of the mixing time we reduced it. And this meant that the company was making around extra 130 hits per year, which is at least $500,000 of earning for each year. And especially when steel is having a cutthroat business these days, especially from the Chinese manufacturers, this was a very, very important work that we did for them. Again, with a very time-bound project, which means that we had to go for a commercial license. The other was working for another. This is a pseudo commercial company. It was with a company that works on development projects as well. The idea was to develop a new design of an impeller with degassing kinetics. The degassing was very important for the solidification for the aluminum refining case. And again, we were forced to go into commercial. We did start with open source, but they were not happy with the progress, the speed of the progress, let's put it like that. And eventually we had to go for commercial license as well. These are some of the open source stuffs that we could do, where we worked on a baffle design in a shell tube heat exchanger. It's a very small, non-time bound project, so there was not much of a time bound in this, and here we could actually optimize the baffle cuts and the distance between them without compromising the pressure drop. So it was a small scale project, but then it gave us the opportunity to use the open source license. The second one was a commercial project as well. Okay, I should have put this before. It was an industrial project where we actually developed the heat exchanger, also for an European company here. We tried to improve the heat exchangers, basically that was using for desalinated crude oil. Okay, this was an open source indeed, where we actually worked for again a shell and tube heat exchanger. So again, this project was not time bound, and when there is not a time bound, and of course the budget was low, we could actually play with the open source. So wherever the budget is high, the company is offering us a very limited time but a very high amount for per hour basis. The revenue was higher. We were actually also, I wouldn't blame always the company. We were also tempted to try with the industrial commercial license as well. This was not the case. It was an open source, so we could also use the open source capabilities here for the understanding the thermal profiles for the shell and tube heat exchanger. Okay, so this was a small part of what we had been doing since the last 3 years, keeping in mind that I have a full-time job and I have my own research. So coming to the thematic problem or thematic question of my presentation is all about digitalization or digitization, whichever way we say it. And as we know that this digitization was basically kind of like a fusion of the mechanical analog and biological and digital. That's what the whole idea of digitization is all about. And it was kind of tempted to be the fourth industrial, mentioned as the fourth industrial revolution. So here there has been a lot of focus lately, especially after 2010, rather 2020, in fact, when Ursula von der Leyen had laid out that the Europe needs to be digitalized, and almost legacy companies were not so much digitalized, unlike in US. And there has been a huge impetus since then through the Horizon Europe fundings, which are actually few billion euros funding. And these fundings are basically focusing only on digital revolution, or we can say the fourth industrial revolution. Here, we try to grab this opportunity because this is a great opportunity. Especially the funding was a support for SMEs and startups, as you can see in the seventh point. The key priorities of European Union was to give a single digital market, to give a digital infrastructure and connectivity, trying to include AI and emerging technologies all in one system, digitalizing skills and education, a very important factor, digitalizing health technology, sustainability and green digital transformation, and support for SMEs and startups. So these three are tried to become the focus of Simulagence because of the catching up the market. And we really were helped by the fact that we could apply for the support programs from the European Union because of their seventh key priority, which is the support for SMEs and startups. So this was, as I mentioned, this was originally it started as a digital agenda for Europe. That was a key initiative all the way back in 2010. But in a big way, it started from 2020, so post-COVID, whereby everything was just because of the pandemic. People started to see that it was very difficult to, if there is a repetition of such events, people won't be able to meet face to face, and digitalization started to gain very rapidly. At least the impetus for digitalization. So here in this case, I would like to say that a small information that we have been working on for the European Union projects. So we successfully passed the round one of the Eurostars Eureka with a budget of 1 million euro, where we had a personal budget of 0.25. Not so bad because of the work that we had to do. It was not too much. The idea was to develop a resource efficient and environmentally conscientious sustainable oven. This oven, basically, it's an innovative idea for optimized cooking performance, where we had to basically try to combine the CFD. That's where I'm referring to this, where we had to combine the CFD. The whole thermal management of the oven was combined with the IoT and the smart sensor applications. So we had a patent with a collaborator. They had a flexible baffle design and built-in image sensors, so whereby we could actually combine all this into one idea, one oven, let's say, and we could predict. We actually are predicting savings of at least 20%. This will be a disruptive technology for Europe as such, and this is already we passed through the rounds. So here, the second one is we just submitted it as well. This was again for a municipality in Turkey. Actually, this was with Turkish partners, where earthquake affected a certain part of the Turkey. As we all know, a very devastating earthquake happened in eastern Turkey, and one of the municipality wanted to completely redefine the way the water is being distributed across the city. And thereby, we had to apply through this strategic budget again, project again, with a total budget of 0.68 million. It's not so high. We are working here not only on CFD, and here I had to mention all this work, since it is not a very time-bound project, and we have a time, 2 years, somewhere 3 years, we are all going to use open source here. Not only that, we are also using OpenSCADA for our work here, and apart from the other applications that has been mentioned here. So this is a project where, indeed, just like the previous one, we could use open source and try to deliver all the results in open source. The third one is about poultry management system. Also a very similar idea to the first one with Eurostars. So that's why we again decided to apply for the same idea. I'm not the coordinator. Simulagence is not the coordinator here. It's another company from Turkey again this time. This has a higher budget, 1.7 million euros. And here, the whole idea of actually combining the thermal management again, trying to get the IoT sensors, do the edge computing. So everything is all together in one system, whereby all the details of the poultries, whether the results are coming, everything will be all monitored, including the feeding system, the watering system, the health monitoring system, and the environmental management as well. Very interesting project. And I wish that this project could be even scaled beyond Europe. In fact, India would be, and the growing countries like China would be very ideal for this, unless India or China doesn't have already this project, this type of system. We are finishing the project submission. We will submit it well before the deadline of March 25. These are the drafts that we are working on, sensing integrated smart sensors. This is a project with the Turkish Aerospace. Sustainable, innovative, and efficient two-engine V2L UAV system. Here again, we are developing CFD systems for fuel cell applications for drones. The third one is the impact accelerator for deep tech. This is basically capacity building for Simulagen. So we are trying to ask money to develop our own capacities, which is actually what European Union is giving as a seventh priority, as I've mentioned to you. And the fourth one is also a very interesting one. It is urban heat island, very, very relevant for India as well, where we are trying to reimagine urban spaces using with the consortium partners. And here we are involving the municipalities, the NGOs, as well as the research organizations and the SMEs like Simulagens. So these are the four main things that I have at hand. So pretty much busy with writing proposals and making it pass through. There will be probably few more coming by, but this is enough for the middle of 2025. So coming to the question of, or rather the point of what Dr. Gupta was mentioning in the previous presentation, what are the employee expectations, and most important is employability. Employee expectations. I'm not a company with Elon Musk's habit, so I will give my employees time to breathe, of course, and time to innovate themselves. So this is the four things that I thought could be very interesting for the expectations from our side: is need for continuous learning and upskilling, cross-functional collaboration and communication skills, very important communication skills, work autonomy and drive of innovation, ethical use of data and knowledge of sustainability goals. These are four important things that as a EU startup, I'm expecting from my employees as well. And for the employability, apart from the technical skills, industry-specific knowledge and soft skills, I think these are three that are quite obvious and are quite expected. The fourth one, I think, is really very important, which is an entrepreneurial mindset, which means that at some point, I would want my employees actually to build up their own and move on. So that's the whole idea, that I don't want to retain them. I want them to move on and with their own ideas, and they can develop. So this developing and co-developing, this is the expectation of Simulagens in terms of employer. I think there are just two strategies, corporate strategies, cooperation strategies that we have with industry and academics. It's a bit of my own thought process, so I don't know if this is relevant at all. We can't find this anywhere. It's my own structure. So for the industrial cooperation, we start with the topic. We do the market analysis. As you can see with the arrows, you can just follow the arrows. And we create a task. This task, either it is already given clearly by the company. Most of the time in Europe, I've seen that the task is not clear for them. They just know that they have to do CFD, and that's it, and which is actually a very ridiculous thing, because unless they have a clear idea, we can't move on, and then at the end we have to propose something back. So there is an adaptation, a small loop that is needed here. After that, we start with the principal case. We call it as version 1.0. We go for the iterations as it is seen here, and then of course with the discussions of with the companies, we finally reach the desired version. Until then, until a new topic is again delivered. So this is the closed chain process. This improves the main aspect of this is that we are working in very close cooperation with the industry. I've been using this model with 3 industries already, and it is pretty much successful. Sure. So this is the academic cooperation while we are working with some universities. Started my cooperation with KU Leuven directly, and this is kind of like cooperation that we're developing also for all the European projects that we are working on this aspect as well. These are the extended lists. There's no need to go for that. And here is the last slide. Thanks for listening. If you have some questions, please ask. And these are the immediate partners that we have, and we thank all of them for providing us interesting projects and funding. Thank you very much.
Thank you so much, Dr. Datta. Dr. Abhishek Datta is also one of our esteemed faculty partners of Open Forum. So thanks a lot for your talk.